Yep, put on your MUC boots. We are solving this problem with MUC. Just to be clear, it's first order because of the first derivative. That's the highest derivative. It's linear, constant coefficients, 1 and 3 on the dependent terms. And the right side depends, it's a constant or depends on the independent variable x. You could use integrating factor here. You could use MUC. It's not separable, so you're not using separation of variables. Now, for a MUC solution, we know that our solution all the time, solution will be y of x, and it'll be y sub h plus y sub p, where the y sub p will be a particular solution based on the form of the right-hand side. Y sub h is the homogeneous solution corresponding to the associated homogeneous equation, where you take the full left side and set it equal to 0 over here. Once you have those two terms, the y sub h, the y sub p, you put them here, add them up, there's your solution. So let's do that. Let's first find y sub h. All right, so find the associated homogeneous solution, find y sub h. What's that going to be? You're going to solve the left side of the equation, y prime equals 3y, set it equal to 0. You would move the left or the linear term 3y to the right-hand side, solve this. You should know what this solution is, and it's a constant e to the negative 3t. There are several ways to solve that problem: through separation, through integrating factor, through MUC, through those three. And you should try that, but it's helpful just to know that that's the solution. So a e to the negative 3t. So far our solution, y of x, would be a e to the negative 3t. The only way this a gets recovered is with our initial condition, which we'll do later. Now we need to find y sub p. Find y sub p. And y sub p, find y sub p equals, and you pick a y sub p based on the form of the right-hand side. And what we mean is, what's a possible solution, or what would a solution look like that solves this equation? For example, could y be a constant? The answer is no. Like, could y be 7? No, because you'd put it here, that would be 0. This would be 21, and 21 is not equal to 4 cosine 2x. Y could not be exponential because you'd have exponential plus 3 times that exponential. That's also not trig. You need your particular guess, a solution for y to have this form to it. And since you're taking the derivative, you also need a sign in there as well for your form. So we're going to ignore the 4, pay attention to the 2x. And our guess for y sub p is going to be an arbitrary constant b cosine of the 2x. And again, you're using 2x because there's a 2x in there. And then plus c sine 2x. That would be our choice for y sub p, whether or not the right side were 4 cosine 2x or for sine 2x. We would still pick this for our y sub p. Then to figure out or determine these undetermined coefficients, you take y sub p, this whole thing, and plug it back into this equation. Y prime plus 3y equals 4 cosine 2x. So let's do that. We need, if y sub p is b cosine 2x plus c sine 2x, we need y prime. So again, we need y prime, we need a 3y, and then add them up and set it equal to 4 cosine 2x. So y prime is negative 2b sine 2x plus 2c cosine 2x. So there's y prime. We need 3y. So let's multiply the original y sub p by 3. Now we have 3b cosine 2x plus 3 sine 2x. We're going to add those up and set it equal to the current left-hand side, which was the 4 cosine 2x. 4 cosine 2x. So we have, let's see, let's gather some like terms. We have sine 2x, and our coefficients are 3c and a negative 2b. So 3c minus 2b for the sine 2x plus Then we have on the cosine 2x terms, we have a 3b and a 2c. So plus 2c plus 3b for the cosine 2x. And now you compare up coefficients. The left hand, let's see, the left-hand side of our equation has a 4 on the cosine 2x piece. Let me get, yeah, a 4 on the cosine 2x piece. There's the 4. That means 4 is equal to 2c plus 3b. Let's write that out. 4c is equal to, or no, rather 4 is 2c plus 3b. Then we need, use that color, 3c minus 2b. That's equal to 0 because on the left-hand side, there is no sine 2x term. So 0 is equal to 3c minus 2b. Let's call this equation 1, this equation 2. We have a system of 2 equations, 2 unknowns, c and b. We need to do something to figure that out. You could do some sort of canceling. You could do some sort of substitution. So maybe I'll do a substitution since we have 0 right there. If we worked with the second equation, we would have 3c is equal to a 2b, and c is 2/3 of whatever b is. Now let's take that and put that into equation 1. Into equation 1, we would have 4 is equal to 2 times c, that's 2/3 b plus 3b. 4 is 4/3 b plus, let's see, that's 9/3 b. That's 13/3 b. 13/3 b. And now we can solve for b. b is going to be 3 times 4 over 13. b is 12/13. So we have b now, and then let's plug that back in here. So c is going to be 2/3 times b, which is 12/13. C is going to be what, 24/39. I hope that's correct. I'm going to check my answer. I'll be right back. Yeah, that'll do it. We could reduce this, take out a 3, and that would be 8/13. So let's go with that one. So now we know B, we know C. So our particular guess, if we go, let's go back over here to our y sub p. So now we know y sub p. B, we had said, was 12/13, and then c is 8/13. So we have 12/13 cosine 2x plus 8/13 sine 2x. And let's plug that in to our particular solution. Let's copy that, copy, put that there, okie doke. So right now that's our solution, and that's where we would end if we did not have an initial condition. So now for our initial condition, going to take that, let's go find our A with the initial condition. And again, the initial condition was y of 0 is 1. Let's go over here. I think we need to take that again. Copy. Yep. So with y of 0 being 1, let's just check. Yeah, that was our initial condition. So y of 0 being 1, let's plug in 0, we get 1. All the t's are 0. So this is a e to the 0 plus 12/13 cosine 0. You know what? We need to make that t an x since our independent variable was x in the problem. So we need an x right there, there, and there. That's my bad, but there we go. Then, okay, so plus 8/13 13ths sine 0. What's sine of 0? Sine 0 is gone. That's all 0. Then we'd have 1 is a plus 12/13. Cosine 0 is 1. So a is going to be this 1 on the left side, which is going to be 13/13 minus the 12/13, and a then is 1/13. So let's go back and rewrite. And we would have 1/13 for our particular unique solution. Let's box that in. There we go. There's your final solution for MUC. That does not take a minute. It takes a few minutes. So practice that so you can be quick with it. All right, y'all take care.